scholars! Welcome to another math day. Today we are working on Module 2, Lesson 9. We're going to continue thinking about measurement, and we're going to break apart a liter to understand the size of milliliters. First, let's work on our whiteboards or paper and pencil. If you need to pause the video to give you more time to think, please do so. On your boards, let's write the number bond. 1 kilogram is our whole. 500 is one of our parts. What is our missing part? 500. 500 plus 500 is 1,000, which is the same as 1 kilogram. On your boards, write the missing part. 300 is the missing part. 700 plus 300 equals 1,000, which is the same as 1 kilogram. Write the missing part. It's 400. 600 plus 400 equals 1,000, which is 1 kilogram. Write the missing part. It is 700. 300 plus 700 equals 1,000, which is the same as 1 kilogram. There are 1,000 grams in 1 kilogram. Now let's make it a little harder. 750 is our known part. What is our missing part? 250. 750 plus 250 will equal 1,000. That makes me think of 7 plus 2 equals 9. Then 50 plus 50 equals 100. So together it would be 1,000. Here we have 650. What is our missing part? 350. 650 plus 350 will equal 1,000, which is the same as 1 kilogram. Write the missing part. We have 350 as our known part. What will be your missing part? 650. 350 plus 650 will equal 1,000. Let's do it again. 1 kilogram is the whole. 250 is our known part. What would be our missing part? 750. That's correct. 750 plus 250 will equal 1,000, which is the same as 1 kilogram. 1 kilogram is our whole. 850 is our known part. What's our missing part? 150. Now, let's get started on our experiment for today. Today, we have a lot of materials, and I'm going to be working hard to show them to you, even virtually. We're going to start with some liquid measurement. Let's get going. All right, scholars, you can see I cleared my stuff up a little bit, and I have some water for us today. Before we get started, I want to have a few questions for you. Which holds more water, a swimming pool or a glass? A swimming pool holds more water. Now, which holds more water, a swimming pool or a bathtub? The swimming pool still holds more water. Now, which holds the least amount of water, a swimming pool, a bathtub, or a glass? A glass holds the least amount of water. The amount of liquid a container holds is called its capacity. The glass has the smallest capacity because it holds the least amount of that water. Now, is this container filled to its capacity? Just lift it up so you can see all of it. Nope, it's not filled up all the way. We have some space up here. Now, the amount of water inside measures 1 liter. You might have heard that word when you hear about soda bottles. Those are also 1 liter. A liter is a unit we use to measure amounts of liquid. To abbreviate the word liter, you would use a capital L. You'll see that in some of our work. So let's compare the amount of water by pouring 1 liter into them to see how it fits. I decided to change my angle a little bit so you can watch me pour. Now, we're going to do it in a cup. This container has the size of a cup. Now, do you think this is going to hold more, less, or the same as 1 liter? On your problem set, you have a prediction. I want you to quickly make your prediction on problem A of your problem set. Do you think container 1, this one right here, holds less than, greater than, or the same as 1 liter? You may pause the video until you finish doing that and then come back. Now I'll pour the bottle into container A to confirm our predictions. The top of this does come off, and this is the part that's 1 cup. Now give me some good juju, because now I get to pour. Let's see if it holds more, less, or about the same. What do you think? Does it hold more, less, or about the same? Is the capacity of container 1 more or less than 1 liter? It is less. We see that the liter still has plenty of liquid in it, and the cup only took a little bit of that. Now, does this match your prediction? Did it surprise you, or is this what you expected? Let's mark it on our page. The actual is less. Now, we're going to switch to another container. I returned the water back into the liter, so this is 1 full liter again. Now, we're going to look at another container. This is a pint. Do you think that this contains more or less or the same than 1 liter? I'll show you what it looks like without the lid. Will this hold more, less, or about the same? Circle your prediction on part 1, problem A, on your problem set. And I will pour the water from container A to confirm our predictions. Let's get started. Did this match your prediction? Is the capacity of container 2 more or less than 1 liter? It is less. Does that match your prediction? Did it surprise you? Why or why not? Next to the word actual on the problem A, write less. The pint has less capacity than the liter. Hold on as I reset our water. This container is a quart. A quart is a measurement of liquid, just like the liter is. Now, I want you to predict on your Google Slides if you think that container 3 holds more, less, or about the same as 1 liter. I'll pour water from the bottle into container A to confirm our predictions. Look at that! It is about the same. A quart holds about the same amount of liquid as a liter. Did that surprise you? Does it match your prediction? Mark it on your slide. Write the word actual on problem A. Write about the same. Let me pause and reset. Now, our final container is a gallon. So I want you to think, do you think a gallon, container 4, holds more, less, or about the same as 1 liter? Circle your prediction on part 1, problem A of your problem set. I'll pour water from the bottle into the container to confirm our predictions. Wish me luck, I spilled last time. That's okay. Math's a little messy. Did this match your prediction? Is the capacity of container A or of container 4 more, less, or about the same as 1 liter? It is more. A gallon has a greater capacity than a liter does. Does that match your prediction? Why or why not? Next to the word actual on your problem set, write more. Then come back. We're going to go on to our next experiment. Let me reset my space. We just compared the capacity using a liquid volume of 1 liter. On both the picture on my PowerPoint and in front of me, you see 10 cups. We call all in the amount of liquid volume. Now we're going to partition 1 liter into smaller units. These are called milliliters. Each of these cups measures milliliters. Now to abbreviate milliliter, we would write M and then a capital L. Now we'll partition our liter into 10 parts. Each square of our 10 frame shows 1 part. So this cup, I know you can't see it, so you have to use a combination of looking at the pictures and me, is marked at 100 milliliters. Right here, just about, is where 100 milliliters is. Let me show you. This is 100 milliliters. We'll use it to measure liquid volume that goes into each cup on the 10 frame. Now, how much water is in cup A? 100 milliliters. Now let's continue with each of these. 100 milliliters for all. Let's count them together. 100 milliliters, 200 milliliters, 300 milliliters, 400 milliliters. I'll angle this a little bit more down so you can see that. 500 milliliters. 600 milliliters, 700 milliliters, 800, 900, 1,000 milliliters. I know it's difficult to see, but now we have partitioned out our liter into into 10 100 milliliters. It is poured out and split up. So how many cups did it take to fill? Did we fill with 100 milliliters? We filled 10 cups. Is there any water left in the bottle? Nope. It's all poured out. So we partition 1 liter of water into 10 parts, each with a liquid volume of about 100 milliliters. So let's get count by hundreds to find the total milliliters on the 10 frame. 100 milliliters, 200 milliliters, 300 milliliters, 400 milliliters, 500 milliliters, 600 milliliters, 700 milliliters, 800 milliliters, 900 milliliters, 1,000 milliliters. How many milliliters are in 1 liter? 1,000 milliliters. So, let's think about an equation. 1,000 milliliters divided by 10 equals 100. Why does this make sense? Now, you can answer that on your problem set. You can include the equation written. I will also be sharing a sample sentence of this answer on your slide. Now, we're going to empty the water back into our liter. I know this is hard for you to see, but here we see tick marks along the cup. Each of these tick marks represents a 10. So if we divided 100 into 10 equal parts, how many parts would there be? Well, we know 100 divided by 10 equals 10. And that would mean 100 milliliters divided by 10 will also be 10 milliliters. That's a solution to problem D on your problem set. You should include the equation in your work. Now this one we're going to imagine rather than do. I want you to think, what if I had a beaker, a small tool that I can use to pick up small amounts of water? Look at the picture here. How many drops would you think it would take to fill an entire liter with that tiny little syringe? It would take 1,000 drops. The syringe can grab 1 milliliter of each, and then it would put it all back into the liters. It would take 1,000 drops. That would be your solution for problem E. Now, we did a lot of the problem set together, but there are still some slides for you to practice. You should also use the challenge slides if you have the time. Afterwards, when you are done, you should head over to Edulastic as always and work on your exit ticket. What an interesting video today. I'll talk to you later. Bye.